Hi guys. Okay, so today we're going to look at simplifying radicals with I. And I know right now you have no idea what I is, but we're going to get to that. So my first question to you is, what is the square root of 25? What times itself gives you 25? Well, the square root of 25 is 5 because 5 times 5 is 25. Also, you could say negative 5 times negative 5 is also 25. So both of those can be the square root of 25. What about the square root of negative 25? What number times itself gives you negative 25? There is no number, because whatever number you have, if it's a positive number, a positive times a positive would give you a positive 25. If it's a negative number, a negative times a negative would give you a positive 25. There is no way to multiply a number by itself and get a negative 25. There is no real answer to this. And that is where the imaginary unit comes in. Now, the imaginary unit, we use the letter I, and the letter I is equal to the square root of negative 1. So I is the imaginary unit or the imaginary number. And I is equal to the square root of negative 1. Now, where does this come from? In order to answer where this comes from, let's go back a little further into the school year to when we learned how to solve quadratic equations having real roots. For instance, if we had x squared minus 4 equals 0, we could use the difference of two squares because the square root of x squared is x and the square root of 4 is 2. And this would factor to x plus 2 times x minus 2, and that would give us 0. We would set each factor equal to 0. For the first little equation, we subtract 2 from both sides, and we get x equals negative 2. For the second equation, we add 2 to both sides, and we get x equals positive 2. Now, there is another way to look at this same equation. It is possible to add 4 to both sides and say that x squared equals 4. Now what we would want to do is take the square root of both sides. But, and this is why we don't do this very often, the square root of 4 is not just 2 because it wasn't written as the principal positive square root of 4. It is positive 2 as well as negative 2. So this has the same two answers, x equals 2, x equals negative 2. Okay, we don't usually use that method because we usually forget one of them and only say x equals 2, but it's a valid method. Now, what happens is imaginary numbers occur when a quadratic equation has no roots in the set of real numbers. So for instance, x squared plus 1 equals 0. This is not a difference of two squares. This is a sum. Okay, it does not factor. So the only way to solve this would be to do what we did in the second method, which is subtract 1 from both sides, and we have x squared equals negative 1. Now, when we square root both sides, we have x equals plus or minus the square root of negative 1. What is that? That's the imaginary number, and this is x equals positive and negative I. So x is the imaginary number. So now we're going to take what we did in the last unit and combine it with the imaginary numbers. So if I want to find the square root of negative 16, that's like doing the square root of 16 times the square root of negative 1. We know that the square root of 16 is 4, and we just learned that the square root of negative 1 is I. So our answer is 4i. If we look at the next one, this square root of negative 121, that's the square root of 121 times negative 1. We know, because we know our perfect squares, that the square root of 121 is 11, and the square root of negative 1 is I. So we have 11i. Let's try another one. Don't forget to bring down your coefficient 3. We know the square root of 4, and we know the square root of negative 1. The square root of 4 is 2. The square root of negative 1 is I. Now we multiply. 3 times 2 is 6, and keep your I. Very good. Now if we look at the next one, I bring down my 3. I know the square root of negative 1, but I do not know the square root of 6, and there is no perfect square that goes into 6. So this time I have 3, the square root of negative 1 is I, and I keep the square root of 6. And now I'm done. Okay, 2 more. Number 5, we're going to break this up into 3 parts because I have my negative 1. As soon as I see a negative, I know I have negative 1. And what's the perfect square that goes into 12? It's 4, and it goes in 3 times. Now the square root of 4 is 2. The square root of negative 1 is I, and the square root of 3 I don't know, so I keep it. And my answer is 2I radical 3. One more, just to be sure. So the square root of negative 27. Again, I have that negative, so I'm going to put that negative 1 in there. The perfect square that goes into 27 is 9, and it goes in 3 times. So the square root of 9 is 3. The square root of negative 1 is I, and I do not know the square root of 3, so my final answer is 3I radical 3. Okay, guys, so this is what we've learned, that the imaginary number is the square root of negative 1, and we write it as I. So when we are simplifying radicals, if ever there's a negative, we pull that out as I. All right, see you soon.